Please write the heading heating effect of electric current. Heating effect of electric current. All of you can see the screen, right? Heating effect of electric current. Please listen. When you use the electric bulb, the old electric bulb is using this principle, heating effect of electric current. Suppose I have a battery. And this battery is connected across a bulb. What happens? The flow of the charges take place, or flow of the electron take place from one terminal to the other terminal. There will be a flow of electrons take place. This is the filament of the bulb. Look at this. What is this? This is the filament of the bulb. As the electron passing through the filament of the bulb, what happens? If you look at the filament of the bulb is actually produced by using a metal, tungsten. I am talking about the old type of bulb, not the latest one. I am talking about the old type of bulbs, tungsten. It is a chemical element. So what I am saying is the electron will be flowing from one terminal to the other terminal if we connect a battery across the bulb. The filament of the bulb is made up of using a metal, tungsten. The tungsten has high resistance. High resistance means the current find it very difficult to passing through the tungsten element. The electron find it very difficult to pass through the tungsten filament. So the electron, as the electron moving through the tungsten filament, it will collide with it will hit the molecules of tungsten. As the electron moving through the tungsten element, what happens? The electrons will hit the atoms of the tungsten. As the electron hit the atoms of the tungsten, the heat will be generated. Look at this diagram. Actually, this description is not there in textbook, but in order to make you understand. What is the current actually? Current is the flow of the electron. The electron is flowing like this. As the electron passing through the filament of the bulb, what happens? It undergoes the collision. With the atoms of tungsten. Understood? This is the atoms of the filament. As the fast moving electron hit the molecule atom, what happened? Heat will be generated. Understood? The heat will be generated. This electron rebound and hit another atom. In this way, the electron will be moving like this. Every time it hit the atoms of the tungsten or filament. As it hit the atom, the heat will be produced. That heat is the glow of the light, appeared as the glow of the bulb. Understood? So I am talking about the heating effect of electric current. All of you please listen. So the electron will hit the atoms of the filament. As a result, the heat will be generated. How much heat energy it will generate, that is what I am going to discuss. Heating effect. First of all, have you heard about the power? Electric power. What do you mean by power? If you buy a bulb from the shop, they will ask you how much watt bulb you require. You will say 5 watt bulb or 10 watt bulb, like that. What do you mean by, have you heard about 5 watt bulb? Samruddhi, Lina, Usma, have you heard about that term, 5 watt bulb?
Yes, sir.
For example, the fan is 50 watt. The AC is 1000 watt. Have you heard about that? What is this watt? what is the unit of power? The power is in terms of, if I am using bulb, the power is heat generated, heat energy. The light generate which kind of energy? Heat energy. Heat energy develop divided by time. In 1 second, how much heat is developed by the bulb? That is power. For example, from a shop, if you buy 5-watt bulb, that indicate that in 1 second, the bulb produce 5 joules of heat energy. In 1 second, the bulb generate 5 joules of heat energy. Understood? Like that. So the power is defined as the heat energy developed divided by time. Heat energy divided by time. The heat energy divided by time. So there is a formula of the power. For the time being, let us memorize the formula. The derivation is not important, but derivation is not actually given in the textbook. Only a single step is given, so the derivation is not important. Just memorize the formula. Only numerical question will be asked. So power equal to heat energy by time. The power has the formula voltage into current. The electric power, let me write the definition of power first. Power is defined as the, let me write the power. The definition is already written, but let me write. The power is defined as the heat energy. Heat energy developed by the bulb in 1 second. All of you please listen. Power is defined as the heat energy developed by the bulb in 1 second. In 1 second time, how much heat energy is developed? That is said to be power. Power is given by the formula. Power is given by the formula V into I. The first one is the general formula. Heat energy by time means in 1 second how much heat energy is developed. Power is equal to voltage into current. Let us learn this formula without any proof. Power equal to voltage into current. This battery will have a voltage. The battery will have certain voltage, and some current will be flowing through the circuit. Understood? Some current will be flowing through the circuit. If you connect a bulb, the battery will have certain voltage and there will be some current. The product of voltage and current is the power. Power means the heat developed in 1 second. Okay. The more power means the more heat energy developed. So more brightness. More power means more brightness. So power is equal to voltage into current, and the formula, and we studied Ohm's law in the previous classes. That V equal to IR. Do you remember the Ohm's law we studied Ohm's law in the previous class, that V equal to IR. So P equal to V into I. V is what? I into R by Ohm's law. So I can replace V by IR. So P equal to IR into I. V is IR, we studied, it is Ohm's law. So we have a formula P equal to I into I is I square. P equal to I square R. Whatever written inside the box you have to memorize. Power has, in 3 ways we can write the formula of power. One is voltage into current. Another formula is I square R. I use the Ohm's law. Then there is another formula P equal to, look here, I square R. Okay, understood. Or P equal to V into I. Understood? P equal to V into I, that is V into. What is I? Look at the Ohm's law. What is I? Can I write I as V by R? Understood? Can I write I as V by R? Is that true? Yes. So this I can be written as V by R. So look at the formula of power. Power equal to V into I. V into I is what? V by R. Ohm's law. So power has the formula V into V, V square by R. The three formulas you have to memorize. So let me explain everything. Let me brief everything. So what I am saying is, I am talking about heating effect of the electric current. First of all, we have to learn power. Power is the heat developed in 1 second. Heat energy developed in 1 second. I am talking about a connecting bulb, okay, or electric heater, okay, something, or bulb or electric heater, something like that. Power of the bulb or heater is what? The heat energy developed in 1 second. The more power means the more heat energy is developed. So power is heat energy developed in 1 second time. So power has the formula V into I. Let us learn without any proof. Power is equal to V into I, voltage into current. And in three ways we can write the formula of power. We studied Ohm's law that V equal to IR, where R is the resistance of the bulb. The resistance will have bulb will have certain resistance. V equal to IR. So V into I, this is the fundamental formula. The formula can be expressed in another format. V is IR by Ohm's law. So this V is IR. So IR into I square R. IR into I is I square R. This formula you have to memorize. Then another representation, P equal to V into I. This is the fundamental formula. P equal to V into I. That is V into I. What is I? I is V by R. R can be taken to the other side. I is V by R. So V into V by R. So power is V square by R. The power has the unit. Power has the unit watt. W. Just like 5 watt, 10 watt, like that. Now listen. Now what about heat energy? For example, the current is flowing through a heater. There is a heater wire connected, or bulb is connected, whatever. Let it be heater wire. There will be question like in 10 seconds, after 10 seconds, what is the total heat energy produced by the heater, like that. So the heat energy in a given duration of time, heat developed in a given duration of the time. Look at this formula. Power is actually heat energy divided by time. Power is what? Heat energy divided by time. So what is heat energy? Power into time. Heat energy is power into time. So heat energy, let me write in words. Heat energy produced in T seconds is denoted by H. This formula is given in textbook. The heat energy developed in T second time. In T seconds time, how much total heat energy developed? What is heat energy then? Power into time. Power, we have three formula. Any formula you can use. The heat power into time. That is good formula. Power into time. Power, for power you can use either V into I can be used, or I square R can be used, or V square by R can be used. So this formula also you have to memorize. The heat energy has the unit joules. The heat energy has the unit joules. It is energy, right? Heat energy is energy. So power has the unit watt, but heat energy has the unit joules. In T seconds time, how much heat energy is developed? So heat energy is given by the formula power into time. Okay, so an electric iron. Electric iron means what is that? It is the iron box. Have you heard about iron box? Okay. An electric iron consumes energy at the rate of 840 watts. In 1 second, understood. What is this watt means? Power. In 1 second, 840 joules of heat energy is produced by iron box. Understood? In just 1 second, 840 joules of energy is emitted by the iron box, electric iron. When heating is at the maximum rate, maximum rate, and 360 watt when the heating at the minimum. Okay. You know that for the electric iron, there are two adjustments, correct? If we keep the low level, the heating will be too less. If we keep the maximum level, the button is kept at the maximum level, the maximum heat energy will be produced. The voltage is 220 volt. What is the current and resistance in each case? It is not tough question. You listen. The diagram is not important here. Without drawing diagram, you can solve it. The battery voltage remains the same because the voltage remains the same. It will not be changed. In our house, the fixed voltage is coming to our house. That voltage is fixed. It never changes. 220 volt is the voltage coming to our house. And across this battery, let me say battery for the time being, let me say battery. Across this battery, an iron box is connected. Let me draw like this. Iron box will have resistance, right? This is iron box is connected, having some resistance. Some current is flowing through the iron box. If the iron box is kept at the maximum level, 840 watt is the power. This watt means it is power. You know that the power has the formula voltage into current. Is that correct? All of it clear? Power has the formula voltage into current. Is it correct?
Yes, sir.
Yes. So if the maximum level the power develop is 840 watts. Understood? Mentioned in the question. At the maximum level, the electric iron produces the energy, a heat energy, 840 watts in 1 second. Power equal to 840. Let me substitute P as 840. In this formula, let me substitute P as 840. Voltage is fixed quantity, 220. Current, I don't know. I don't know how much current is passing through the iron box. I don't know. It's a very simple question actually. Power equal to voltage into current. That formula is used here. So when power is 840 watt in the maximum level, when the power is 840 watt, you substitute P as 840. Voltage is 220. We have to find out. So when the power is 840, what is the current? This 220 can be taken to the left hand side. Is it okay? I equal to 840 divided by 220. The I equal to, the current is, it is there in the question. We have to find the current. Let me do the division. 0, 0 cancel. And I don't want to explain the division step. I don't want to explain the division step. 840 divided by 22. You can do the division later. Let me save time. 3.8 ampere. So when the power is 840 watt, the current through the iron box will be 3.8 ampere. The current will be, I will delete it later. Current will be 3.8 ampere when the power is 840 watt. Not finish. I want the resistance. It is mentioned in the question. I want the resistance of the iron box or electric iron. What is the resistance of this iron box? That we can use Ohm's law. If there is a question about resistance, we can use Ohm's law. V equal to I into R. We studied that. Ohm's law we have already studied. In any question, if they are asking about resistance, you just use Ohm's law. V equal to IR. we know the value, I is also given. So R equal to V by I, correct? R equal to V by I. When the power developed is 840 watt, in that situation the resistance of the iron box will be V by I. V by I, V is 220, correct? V is 220. And I is what? I got the value of I, 3.8 ampere. You can do the division later. If you have any doubt about the division, remember the point can be, you can avoid the point, because keeping point in the denominator, that if you keep the point in the denominator, the division will be very hard. So better method is you better remove the point, decimal. That is better, so that multiplying 10 numerator and denominator, that will not change the fraction. Then after that you can do the division. Division I don't want to discuss. You can do the division after the class. If you have any doubt about the division, you can tell me, I will discuss that. So you can do the division later. Let me save time. 57.8 or 9, okay, whatever, no problem. Ohm, this is the resistance. So remember the value of I and R, where the power is kept at the maximum level. Iron box, the power is kept at the maximum level. The current will be 3.8 ampere and the resistance will be 57.8 ohm. It's a very simple question, I think so. The question is, let me read it. 100 joules of heat is produced in each second. What is the meaning? 100 joules of heat is produced in each second. In 1 second, this much heat is developed. Maybe heater or iron box or bulb, whatever. In 1 second, this much heat energy is produced. That is watt actually. 100 watts. Clear? That is the meaning of power. 100 joules is 100 joules heat energy is developed in 1 second. So what is the power of that electric device? The power of the electric device will be 100 watt. 100 watt means in 1 second 100 joules of heat energy is produced. So P equal to 100 watt. The resistance of the iron box or heater, whatever, I don't want to draw the diagram. The resistance is given as 4 ohm. What is our question? What is the potential difference or voltage connected across the resistor? What is the potential difference means voltage, that is a question. So PRV, we studied 3 formulas for P. Which formula is the best formula? We studied 3 formula for finding power. One is P equal to V into I, but I is not mentioned here. So another formula we studied is P equal to I square R. But I don't want to use this formula because I is not mentioned here. And we studied another formula, V square by R. This thing will be much better, convenient. P is given in the question, so we have no need to worry about P. P is given in the question. R is given, yes, R is given, can be used here. P is given, R is given, I can easily find out V square or V. So among these 3 formula, the third formula is much convenient. Understood? All of you clear? Is that okay? Let me use the third formula. The 3 formula you have to memorize. P equal to V square by R. But I want V. Okay, let me substitute the value. P is 100. V square, V I don't know. By R. R is the resistance. Which is 4 ohm. Question is simple. You can do the cross multiplication like this. So V square equal to 4 into 100 or 400. V equal to root of 400. Root of 400 means it is 20. If you don't understand, you please tell me. 20. Why 20? Because 20 square is 400. Understood? 20 square is 400. So square root of 400 is 20. So the voltage or potential difference will be 20 volt. A question, you have to send me the solution through WhatsApp. I don't want to you write a longer sentence. Okay, I don't want to write a longer sentence. Power equal to 100 watt. Current equal to 4 ampere. Find V. If you know the formula, you can do it. Find the voltage or potential difference. It's a very simple question. Okay. Find the voltage and resistance. Find the voltage and resistance. The two questions are there. It's a very simple problem. You please try it. Look at this problem taken from textbook. Exercise. Compute the heat generated while transferring 96000 coulombs of charge in 1 hour through a potential difference 50 volt. It is actually it is a tough question. Okay, 96000 coulombs of charge in 1 hour through the potential difference 50 volt. How to do this question? We studied that the heat is our question. Heat is heat in 1 hour. Understood? What is our question? We need the heat energy develop in 1 hour. Our question is heat develop in 1 hour time. Heat is continuously developing in a 1 hour time. How much heat energy is emitted? Heat energy denoted by H. I explain the formula power into time. I explain this formula. I will show you. The heat energy is equal to power into time. In T time duration, during T seconds, how much heat is developed? Power into time. So what I want, heat develop in 1 hour time, H equal to P into T. Let me write once again. H equal to power into time. Time is 1 hour. Here T is what? T is 1 hour. Let me write here. T is 1 hour. I want to write it in seconds. I want to convert to seconds. Because second is our unit, right? Second is our unit. Or let me do one thing. Let me discuss in another way. Listen. Power has the formula voltage into current into time. Power has the formula voltage into current. We studied that. Power has the formula voltage into time. Voltage into current. Exercise. Voltage is given. We need not worry about voltage. It is 50 volt. Voltage is 50 volt. We don't have any confusion. Is the I given? No, I is not given. But we studied current in the first class. Remember, I think a few of you absent in the first class. The current, if you don't remember, I will write here. The current is equal to charge flow divided by time. Charge flow divided by time. That is current. Charge divided by time. Current. Actually, I discussed the problems. I explained this formula in the first class. I equal to Q by T. We studied that formula. Q by T. Understood? In T time, Q charge has crossed. Clear? Understood? In T time, suppose Q charge has crossed. Then current equal to Q by T. So the question is, the Q is given. That is why I'm going to use this formula. Current is not given. The Q charge is given. So current equal to Q by T. I will clarify all your doubt, but let me finish it. I can be written as Q by T. In 1 hour time, 96,000 charges has crossed. So the current is Q by T. Q by T indicate that in unit time how much charge will flow. So I equal to Q by T. Never forget this formula. I is Q by T. Into T is there. Actually that T will be cancelled. We need not worry about T. When you write the formula, you can see that T will be cancelled. T mean 1 hour. Understood? T is 1 hour, but 1 hour, both numerator and denominator, T cancels. 50 into Q. Q is the charge. It is 96,000. I am finding heat energy, so joules. The heat has the unit joules. We get a very huge value of heat energy in 1 hour time. Let me find it. 1 minute. Let me find the value. Just please, I hope you have understood. Look at this question. This one. Look at this problem. Today I will discuss only the problems related to power and heat energy. That's all. An electric iron of resistance 20 ohm. An electric iron has the resistance 20 ohm. Current is 5 ampere. The heat developed in 30 seconds is our question. Time is 30 seconds. Time is mentioned. The heat energy developed in 30 seconds time. During 30 seconds time, how much total heat energy developed by the iron, electric iron? We have the formula heat is equal to power into time, PT. You read this formula again and again, then you will never forget. H equal to PT. Understood? H equal to PT. Power into time will be the heat energy. P is not given. Can I find out P? I and R given. Understood? I want P. I and R given. Power has 3 formula. P equal to I square R. Do you remember that formula? P equal to I square R. 3 formula we studied. Among that 3 formula, I square R is better. Because I and R both are given. So P equal to I square R into T. H equal to heat equal to PT, that is I square RT. I square, I is what? 5 square. R is 20. T is 30 seconds. So let me multiply 25 into 20 into 30. 15000 joules. The unit of heat energy will be joules. So in 30 seconds time, this much heat energy will be developed, produced by the electric iron.